So you might be asking, well, what are we doing? We're learning so much about the theory here. How do we apply that? And that's a legitimate question. Here's how. So you'll be asked, of course, you should still understand the theory because the theory is very important, but you will most likely get questions like these as well, where they will say, okay, determine the mechanism to which the reactions will go through and then draw the product. You may be asked to, of course, as well, draw the mechanism. So we'll do both. In this reaction, what you need to do is you need to apply what you learned to draw the product and determine what mechanism it's going to go through. So this is how you would start. You would start with the alkyl halide, and then, of course, identify your sp3 carbon. So here's our sp3 carbon. Right there. So you know that there is a bromine attached to it. That's going to be your leaving group. X. Your X, okay, then that's funny. And then you need to identify then what kind of an alkyl halide it is. It's a secondary alkyl halide. So secondary, the more substituted, it tends to go more toward SN1. However, you're not done. You need to go next to the solvents in the nucleophile. So if we split this NaOH, it would be Na plus, that's a spectator ion, and OH minus. And we know that this is a strong nucleophile because it's charged. And we know DMF is a polar aprotic solvent. So all of these point toward an SN2 reaction. An SN2 reaction. So you see how we discerned all of this? Alkyl halide, strong nucleophile, polar aprotic solvent. Now to draw the product, and we're going to show you the mechanism. I'm going to erase this because I need and erase this right here. So we can put this again here. That's a secondary aprotic. And again, this is going to go through an SN2 reaction. What you do is you bring the OH, that's your nucleophile. And that's a backside attack. And now all you have to do is draw the opposite configuration. And the way to do that is to switch now. Okay, the new group is the OH. So we're going to give this the solid wedge. And then H will be now in the back because again, it did an inversion of configuration. So whatever you started with here, so if this were 1, 2, 3 R, this is S. This now would be the R configuration. And of course, the name, you would name it. Now let's go to the next one. The next one would be, and pay attention to the mechanism here. The next one would be same thing. We need to discern what do we have. So here's our sp3 carbon where the leaving group is attached. What kind of a alkyl halide is this? Is it tertiary, secondary, primary? Well, this sp3 is attached to 3 other carbons. Here's 1, there's 2, there's 3. We know that tertiary carbons and SN2 don't go together, alkyl halide, so we must have an SN1. But let's actually continue and see what other information is given to us. And if we look closely at this, we notice that we have no strong nucleophile. So this is a weak nucleophile. Plus, this is a polar protic solvent. Polar protic solvents. All of these hint toward an SN1 reaction. So let's look at the mechanism then. The first step, the rate limiting step, is breaking this carbon halogen bond. So this leaves a positive behind it, and of course the chlorine is floating around. Now here's a chance for our nucleophile to attack, which is this. Right there. Now, there's a problem here. And the problem is that the oxygen has 3 bonds, and that's a positive, and we know that's never a good thing. So what would happen then is you need to get rid of this bond right here, this hydrogen attached to it. So we need something else to obviously form or remove that H, and you can use Cl or another remember, this is an acid-base reaction. Or just OCH3. Now, the last thing you would like to do, plus HCl. The next thing you have to do is, again, since we have check for stereochemistry, can you have do you have a stereogenic center? And you do. So if you have a stereogenic center, then you are most likely going to have a stereogenic center afterward, and of course, 2 different isomers, 2 stereoisomers, enantiomers. So you have to draw both of them. So the easy way of doing it is just alternate between the methyl and the methoxide here attached, the OCH3. So I'm going to start by making this methyl hatched line, and of course the ethoxide or methoxide as a wedge, plus this one should not be made. I'm just needed to watch how I'm alternating. So that indicates that we have a racemic mixture. Very good. So please study this. Think about those theories all the time, be able to apply them, and do as many problems as you can from the homework. The earlier you start, the better, because then these will be also in competition with next week's reactions. So then you're going to have now 4 things to look forward to. Okay, 4 things to really determine which mechanism is the plausible one, and then you can solve problems very easily. Again, if you know those criteria, the criteria for the SN1 versus SN2 reactions. And again, please bring questions when we meet next time.